The next section for Chapter 7 is Section 7.4, which talks about inverse trig functions. So here, and let me get rid of this. So here at the top, whatever. Here at the top we have the inverse sine function. So if we want angles from a function, if we are given its value, we can go back by hitting the second sine button on your calculator. Here's the actual graph of the arcsine function. Notice that if you do sine, arcsine, or arcsine sine, they both cancel each other out. So here, if you do the arcsine of square root 2 over 2, well then it's 45. But also, since that's a reference angle, sine is also positive in quad 2, which makes this 135, which is 180 minus 45 to get your 135. Okay, for B, when we want to do the arcsine of negative square root 2 over 2, square root 2 over 2 is 45 again for sine. But since we are negative square root 2 over 2, we're looking at the two other quadrants, which is in quads 3 and 4. So that would be 225 and 315. Remember to get reference angles. It's always target the x-axis. So to get the third quadrant one, add it to 180. To get a fourth quadrant angle, you subtract it from 360. An arcsine of 5/4. Well, 5/4 is bigger than 1. Sine can never be bigger than 1. So this just does not exist. Using our calculator to find inverse sine functions, we want to find the approximate value for arcsine of 0.71. We pull up the calculator. Sine 0.71. Enter. I am in degrees, so 45. Oh, it's expressed the answer in radians, so I need to change my mode. Enter. Second. Enter again, and it gives me in radians. So we're rounding to 5 decimal places. So 0.79, 789498, so which actually means 7895. So this one is 0.7895. If we do the arcsine of 6/7, arcsine 6/7, enter, 0.02969, but there's a 6 behind it, which makes it actually become 0.297. So this one, 1.0297. Find the exact value of cosine, then arcsine of 513. So I'm going to draw a right triangle. Say that is theta. If it's sine, opposite and hypotenuse, missing side Pythagorean theorem will tell us it's 12. So if I'm looking, this is like saying that that is theta. So if I'm looking for cosine theta, theta is adjacent over hypotenuse, 12 over 13. That is the answer. Moving on, we have arc cosine. Here's our function, here's the graph. Notice that they cancel each other out if you do cosine and arc cosine, or vice versa. So when is cosine square root 2 over 2? 45 again. But it's also in quad 4, which is 315. Cosine of negative square root 3 over 2. Well, cosine of square root 3 over 2 is 30. That's the reference angle. And if we're negative, we're talking about quad 2 and 3. So this would be 150. 180 minus 30 is 150. And then 180 plus 30 is 210. And then the cosine of 1. Well, if you think about your cosine graph, it looks like this. So these are the spots that it's 1 at. 0 and 360. It says write the cosine arcsine x as an algebraic expression. So I'm going to draw a right triangle again. So if cosine, they're saying arc cosine is x, opposite over hypotenuse, right? To make x a fraction, it's x over 1. The third side would be 1 minus x squared, Everyone good so far? Then this is theta. So if we want cosine theta, that's what we're really looking for. Like that's really theta. This is equal to the adjacent side here, the hypotenuse side. So it's just 1 minus x squared. This last example kind of mimics the one before. It has to do with a similar situation where I'm going to draw my right triangle. Arc sine again is x, so 1 x square root 1 minus x squared is our three sides. This is theta. So they're really looking for cosine of 2 theta. That's what they're looking for, which means we can choose any of the functions that we want. I'm going to choose 2 cosine squared theta minus 1. Why not? So 2 cosine theta is square root 1 minus x squared. And we're squaring it, minus 1. So square root and square go away. So 2 times 1 minus x squared minus 1. So distribute the 2. 2 minus 1, 1 minus 2x squared is our final answer. And that actually is all for section 7.4. That is a rather short one.